Namaskar, welcome to Exercise Explained. In this video, I would be doing question number 1 and question number 2, exercise 3B, machines, ICSE 10th physics. Hope you guys would like the video. If you like it, do share it with your friends and consider subscribing to the channel. Starting with the first question, so these questions will be based on pulleys. I have drawn some diagrams so that it is simple for us to understand. A woman draws water from a well using a fixed pulley. The mass of bucket and water together is 6 kg. So she has to pull the bucket up. So that means the mass of the bucket and water together is given as 6 kg. So the first thing what I would do here is I would find the weight. Before that I would write the given data. Mass is supposed to be 6 kg and acceleration due to gravity we will consider it as 10 meter per second square. Now we can find the weight, and the weight itself is going to be our load. So I would write weight is equal to load is equal to m into g. So that's going to be equal to 6 into 10. That's going to be equal to 60 newtons. So we have got the weight as 60 newtons. Now the force applied by the woman is 70 newtons. Calculate the mechanical advantage. So it's very simple. The effort is given as 70 newtons. I would write here effort is equal to 70 newtons. Now we know the formula for mechanical advantage, that happens to be load divided by effort. So mechanical advantage will be equal to MA, that is equal to load is our 60 newtons divided by effort is 70 newtons, so that gives us 6 by 7. So 6 by 7 is approximately equal to 0.857. So we get the mechanical advantage as 0.857. So getting into the next question, a fixed pulley is driven by a 100 kg mass falling at the rate of 8 meter in 4 seconds. So the effort required here is 100 kg. Effort is given as 100 kg. It lifts a load of 75 kgf. So the load is straight away given as 75 kgf. So here we know the mass. So I would be writing the mass, that is 100 kg. So 100 kg, when we convert it to newtons, so weight will be equal to m into g. We will consider g as 10 as we did in the last question. So it's going to be equal to 100 into 10, that gives us 1000 newtons. So we got 1000 newtons over here. So after this, calculate the power input to the pulley taking the force of gravity on 1 kg as 10 newtons. So we have actually got the weight here, and this is going to be the input. So after this we need work done for finding power, because without work done we cannot find power. So I would be finding work done. So I would write it as work done. So work done is force into displacement. Now force is given as 1000 newtons, as we can see here. 100 kg we converted it and we got it as 1000 newtons, into displacement is given as 8 meters. So we get this as 8000, and since this is work done, it's going to be in joules. Now we need to find power. Now for finding power, we know the formula for power as work done divided by time taken. Now this comes from 9th standard, I guess. So power is equal to work done divided by time taken. Now how much is our work done? Our work done, we just got it as 8,000 divided by time taken is 4. So we get this as 2000 watts. So we get the power as 2000 watts. Now that we have got the power, uh, the next thing, the efficiency of the pulley. Now we know the input. For finding the efficiency, we can do output by input, but for output we have output is going to be equal to the load. So here I would write output equals load, that is equal to 75 kgf. Now when we convert 75 kgf to newtons, we multiply by 10. So we get this as 750 newtons. So 750 newtons is the output. So we have got output here, and top you can see we have got input. So efficiency formula, we know it as output by input. So I would write the symbol eta, that is equal to, efficiency is always output by input. So that's going to be equal to 750 is the output divided by input is 1000. So we get this as 0.75. So efficiency, we got it as 0.75, which can be written as 75%. So we have got the A part of it here, we have got the B part of it. Now the C part, for finding the C part, we need to find the height to which load is raised in 4 seconds. So for that, we will have to find work done in 4 seconds. But work done in 4 seconds, we have already got it. Otherwise, we can use the formula work done is equal to power into time. Now how much is the power we got? We got the power as 2000 into time is given in the question, as we can see it is 4 seconds. So we get this as 8000 joules. So as I had told you before, we have already got the work done, and it's going to be the same. Still I took out by using a separate formula here. So now that we have the work done, we can find the displacement. So for finding the displacement, we will be using the formula work done is equal to force into displacement, F into S, or S would be equal to work done divided by force. Now work done is 8000 divided by force is, we got the force as 1000. So we get this as 8 meter itself. So it was actually given in the question itself, the work, the height to which the load is raised in 4 seconds. So that was given in the question. I still proved it. So that happens to be 8 meter itself. So this completes this particular video. In the next video, I would be doing question number 3 onwards, the link for which will be provided in the description. If you like the video, do share it with your friends and consider subscribing to the channel. Dhanyavad.